Hello, everybody. This is a recap of what we did in this very last tutorial of COE 318. So the topics we covered here are polymorphism. This included abstracts classes and interfaces, and there was also exception handling, which covers throwing exceptions and catching them as well. So abstract classes. So these classes cannot be instantiated. So we cannot create an object of this class by itself, but it can still be extended, and these subclasses can be instantiated instead, and you can access the abstract classes methods that way. And the subclasses extended from abstract classes are called concrete classes. And of course, just like any other class, abstract classes can also have instance variables and methods as well. So this is how we make our abstract classes. We just put the abstract keyword before the class definition, like declaration. I wrote public abstract class don't make me, which makes don't make me an abstract class. We can then extend the don't make me class with make me instead, just like how we do inheritance. Now, here are some things about abstract classes, and one of these things are abstract methods. So abstract methods cannot have a body, which means you cannot have any content inside at all. They are required to be overridden by subclasses, however. So the subclasses will have the body of those abstract methods. So here is an example. I have don't make me abstract class having an abstract method called makeT, which means I would have to implement the makeT method in any subclass that extends from don't make me. So here's an example. I have the make me instead class, which extends from don't make me, and I will implement the makeT method with the return type void, and I'm going to just print a line of t is made, and that's it. So here's an example. I have a bunch of methods, and I'm trying to extend the abstract class A with the public class B. So the question is, which methods must be overridden by B? Now, the keyword is must, which means any other method which doesn't have to be overridden are going to be ignored in this question. So if you understand how abstract methods look like, or what they look like, then you will know that C and E must be overridden because they are abstract methods, and abstract methods must be overridden if the abstract class is getting extended. So in this case, yes, C and E must be implemented. Okay. We can also use abstract classes as a variable type, which means if you declare variables, you can just write the class, you can just write the name of your abstract class as your data type, but then your value has to implement has to be a valid class or an object of the valid class that extends the abstract class. Okay, here's an example. So according to Java's documentation, there's an abstract class called the abstract map, which is an abstract implementation of the map interface. It requires its subclasses to actually override methods that add mappings for different keys, read those mappings, and even remove them. So, what can we do if we are trying to make a variable of the type abstract map? Well, we can use the variable type itself. Variable type being the abstract map itself, but the reference has to go to an object of a valid subclass which extends from the abstract class. in this example, I'm going to use hash map because hash map actually extends from abstract map. How convenient. And it's also commonly used as well. So we have abstract map being the being a reference to a new instance of hash map. And both have to use the same mappings. In our case, is string to integer. And you will notice that I use string to integer in both. Okay, now that abstract classes are taken care of, I'm going to talk about interfaces. So, what are interfaces? Interfaces define only a set or a list of generic behaviors or methods. And classes can implement interfaces, but they must have methods that are listed in those interfaces. You'll see in a bit. You cannot have anything else other than methods in interfaces. And as for the methods, public methods must be abstract, while private methods can be whatever they are, starting from Java 9 and up. We're not going to use private methods, however. So here's how we declare an interface. We just use the interface keyword, and then we just type the name. Interesting, right? So we have for example, I want to use an interface called thing, which contains some methods regarding some stuff we could do to things. And I'm gonna make a book, which is also a thing. Well, it can do things that a thing can do at least. Using the implements keyword, I can make a class that implements the thing interface, and I will need the methods from thing in order to do that. So here are a few things about interfaces versus abstracts classes. You cannot extend more than one abstracts class, so that's a shame. And there are times that you have a problem with multiple inheritance. So that sucks. Well, you can implement as many interfaces as you want, so this will solve the problem, hopefully. So, one way I could think about those two things would be use abstract classes if you know that your subclasses is exactly something, like how a resistor is a circuit component. And use interfaces if you know maybe your objects can do this thing, but you don't know what it is exactly. So here are some things about here's an example of how we implement multiple interfaces. Now, a very easy question would be what methods must be implemented in book. If you look at the class book, it implements both thing and readable. So in this case, if you look at both interfaces, they all have required methods that are required when we implement these interfaces. So we actually need all three methods. So that would be pickup, open, and read. So here you go. So, of course, just like abstract classes, you can use interfaces as a variable type. And as an example, according to Java's documentation, list is actually an interface that requires classes to have methods for reading, adding stuff, and removing stuff from collections such as arrays. So I will in the data type portion of the variable declaration, I can use the list, maybe a list of integers as the variable type, but the value or the reference must be a legit class that implements this interface. For example, I can use array list, and that works. Just make sure that the type of things to store are the same. So in our case, I would use integer. Okay, now that we got polymorphism out of the way, I'm gonna talk about exception handling. So the first part would be throwing exceptions. So sometimes your methods may need to throw exceptions on purpose, maybe because of bad input. To throw an exception, we use the throw keyword. Then you specify the exception objects that will be thrown. So here's an example. I can throw a new illegal arguments exception saying that n must be 0 or higher. Well, sometimes you have to, because maybe some operations cannot take negative numbers. Now, another thing about throwing exceptions. If your methods will throw an exception in any parts of its content, you have to specify the types of exceptions it will throw using the throws keyword next to the method's declaration. You know that you forget this step when the compiler complains that it cannot resolve this exception. So in this case, I have some method which throws illegal arguments exception, which means that I can actually throw it when I have bad input. Cool. Now, here's a question regarding throwing exceptions. At what values will print n do the following? Display some inputs and throw an exception. For A, if we look at the code, the exception is thrown if n modulus 2 is larger than 0, which means that n most likely is odd because n divided by 2 has a remainder of 1, which is larger than 0 if n is odd. So when that happens, we will throw the illegal arguments exception. Otherwise, that's when n is even. We will just print out n, which is what we need for A. So for A, it would be when n is even, and for B, it would be when n is odd. So there you go. So here's a bit of things about the second part of exception handling, which would be the try and catch. Now, this is pretty much like the receiving end of the thrown exceptions. If you're gonna be the receiving end of an exception, you can try to catch it and do something else rather than crashing your program. So you can use the try catch block to try to run some code, but catch an exception, and then catch an exception, which means you will run something else as soon as you encounter the error. So the try part will run the code you specify in the code block, and then catch will run its code that you write when a specified exception occurs. For example, I have a scanner input and I just take an input. I tried to use the print n method in the last slide, which cannot take odd integers. If I catch that there's an illegal argument exception happening there, I would just print out use an even integer instead of just crashing the program, which is what happens by default. So here is an example using try and catch. Let's see what you learned. What inputs should be used to do the following? Now, what I mean is, what should next int return in order for these three things to happen? For A, we want to display use an even integer. For B, we want to display the value of what we input. For C, we want to display use an even integer, not random junk. If you look at the main method, we're trying to print n, and the arguments we pass would be the next integer we put as in our console input. Now, when I try to run this code, I also want to catch the illegal argument exception, which is being thrown by the print n method, and it only happens if there is not an even integer, which means that when n is odd. We also want to catch another exception, which is when there is a type mismatch, which means that when we have an input that is not an integer, which means I could just say use an even integer, not random junk. Which actually makes sense. Like if you just put in like random junk in the inputs, you're gonna get complaints. You're gonna get complaints. Now, the answer is gonna be for A when you just want to say use an even integer, use an odd integer, and pass it to n. Pass it to print n. For B, we want to display the value of the input, which means we want to run system.out.print line with the argument n, so we can use any even integer. Now for C, which means use an even integer, not random junk, we can pass in anything that is not an integer, because type mismatch happens when you put in something that does not have a matching type as what's being that's what's being fetched here. So we actually reached the end of this tutorial. The tutorial is very short because I don't want you to I don't want to disturb your time trying to study for the exams. So there is no live demo here. You can make up your own exercises or maybe practice using your textbook. And finally, thank you for coming to this last tutorial. Until we meet again, maybe in person. Have a good day, everybody. And that's it, folks. See you maybe someday. Bye.